The last topic for today is lecture number 13 about measure of association between independent variables of different types, regardless of the type of dependent variable. I will return here in the table and will write here regression and correlation. Regression as method for testing of hypotheses about the presence of the relation, and correlation as measures of the strength of relation. But we have here 3 empty cells in this table. So if there is method which could be used for all types, for all scales, for nominal independent variables, for ordinal independent variables, and for interval independent variables. And if this method could be used for nominal ordinal dependent and for interval dependent, this method could be placed in all cells of our table. And fortunately, there is such method. Its name is classification tree or classification trees, and this method works with nominal or ordinal dependent variables, works with interval dependent variables, and works with mix of different scales, and that means that I could copy this method in each cell. I can copy this method in each cell of the table. So, what does that mean, classification tree? I will use again whiteboard. That means that first, in the beginning, in the root of the tree, we have a sample, data sample. Then we divide this data sample in subsamples according to the most important factor. After that, each subset is divided according to the second most important factor. But this second most important factor can be different for the different branches of the tree. So, for example, the most important factor could be, to say, education. And here we will have, for example, high school, and less than high school. And here we will have more than high school. College degree or bachelor or master or doctor, PhD. But for this group here, it is possible next factor to be, for example, gender. one group male, other group female. And for this group here, for example, the second most important factor to be age. Less than, to say, 40 and greater than 40 years of age, and so on and so on. This method, classification tree, makes automatic selection of factors, automatic selection of independent variables. That means that if there is a relation between particular factor and the dependent variable, this factor remains in the model, remains in the tree. But if there is no relation between this particular factor and the dependent variable, then this factor is removed. From the model, from the tree. But classification tree also orders the factors, orders the independent variables in the level of the tree. Upper level shows more important factor. Lower level shows less important factor. And now I will perform this analysis, but as I said, only in SPSS. So I will open SPSS. And we'll open the file. Okay. And I will start with variable view, because for this method is very important. Measures here or scales to be correct. So I will check them. Gender is nominal variable. It is correct. Age is interval. Here in SPSS, word is scale, not interval scale, just scale, but scale means interval scale. After that, marital status is nominal, it's correct. Do you have children? Is also nominal, it's also correct. Highest level of education is ordinal, okay, it's correct. Then major sources of stress in life is nominal, okay. Do you smoke is nominal, also okay. Number of cigarettes per week is scale, is interval, it's correct. And two results. First one, row score optimism is interval, yes, here is scale. And optimism R, this is this variable with three categories: below the norm, in the norm, and above the norm. This variable is ordinal. Here, it is not correct, and I will choose. We have here drop-down menu. I will choose ordinal, and then we'll save the file, and then I'm ready to the classification tree. Now I will choose analyze, after that classify, and after that tree. Now this window appears, and this is warning that we must define correct type of scales here, but we already did, and I will press OK here. And now dependent variable. I will start with first example, nominal or ordinal, in our case ordinal dependent variable, optimism R. So I will move optimism R into the field dependent variable, and now I can target some of these categories, because for us usually these two categories, below the norm and above the norm, are interesting because they shows deviations. They shows how many people are outside the norm. I will target them, and then here I will move all independent variables together. And independent variables are these variables: gender, age, marital status, education, and so on, to how many cigarettes per day. Okay, after that, here we have growing methods. We have here two different growing methods. Chait or exhaustive chait is the same, but I prefer this exhaustive because it's more precise. But there is another method, CRT. By the way, chait means chi-square automatic interaction detection. So this method is based on chi-square. Here we already discussed this method. So CRT, the other method, means classification and regression tree. But my choice is exhaustive chait. But why? First, this method, classification tree or classification tree, so decision tree, was created for a different purpose. This method was created for so-called decision making under risk. And after that, this method is adapted to analysis of relation. And this CRT is better when we use classification tree for decision making under risk. Chait or exhaustive chait is better when we use classification tree for relation analysis. And now we analyze relation. So I will choose child, and as I said, exhaustive child is more precise than just child. So I will choose exhaustive child. After that, I will press this button, output, and here I will want to see tables and charts, not only tables and not only charts. And I will choose scale 100%. Also, there is 4 tabs, not only 3. In the second tab, in tab statistics, I will uncheck risk and classification table. I will uncheck them because they are very important when we use classification tree for decision making. They are very, very important in this situation, but when we use classification tree for relation analysis, these 2 options are irrelevant, and I will uncheck them. After that, I will press continue and will press criteria. First, here I will change the depth of the tree. Here, depth of the tree, it's recommended to be equal to the number of factors. Since we choose 1, 2, 3, 4, 5, 6, 7, 8 factors, I will choose here 8 levels. This is maximum depth. Also, here in intervals, in this field value, it's recommended to put maximal possible value, and maximal possible value here is 64. So I will write here 64, and we are ready. I will press OK, and let's see the result. First of all, this table, model summary, this table consists of 2 parts: specifications. These are specifications we already made, but the second part is results. And in this part, we can see that only one independent, that there is only one independent factor. That means that only that means that there is only one relation between age and optimism. And here we can see that the tree consists of 5 nodes. 4 of them are terminal nodes. Terminal nodes are these nodes which are not divided. This one is not terminal because it is divided, but these 4 nodes, they are not divided, and they are terminal nodes. And the depth is 1. This tree has only 1 level. So after that, we have 2 tables about the target categories. We targeted 2 categories, below the norm and above the norm, and we have 1 table for below the norm and 1 table for above the norm. And here we can see that this node number 1, here the percentage of persons below the norm is biggest, is largest. And in node number 4, in the opposite, percent of persons below the norm is smallest, lowest. And in the tree, we can see these two nodes. Node number 1, with the largest percent of persons below the norm. Here is the node number 1. Here is this percent, 21.2% of persons are below the norm, but since the independent variable is age, these persons here are less than or equal to 31 years of age. So if somebody is his or her age is less than or equal to 31 years, he or she will be in node number 1 with the highest percent of category below the norm. Node number 4. Node number 4 here, and percent of persons below the norm is 7.6, and in this node, and node number 4, are persons above 47 years of age, are persons older than 47 years of age. So this table was for the below the norm. Next table is for the other category above the norm. Here, node number 4 is the node with the highest percent of persons above the norm, and node number 1 is the node with the lowest percent of persons above the norm. And we can see here again on the tree. So above the norm here in the node number 1, 10.6%. This is the lowest percent of this category above the norm among all 4 nodes, 4 terminal nodes. And in node number 4, here is the percent, 29.5% of persons are above the norm. And we can see these percentages as values, as numbers, and we can see these percentages as charts with different bars, with different colors represented different categories of dependent variable. So you see that we choose all 8 independent variables, but analysis reveals that only one of them has impact on the dependent variable. But this example was to the first column here. we use classification tree with ordinal dependent variable. Now I will show you how to use the same method with interval dependent variable. So I will choose again analyze classify tree. Again we'll press OK, and we'll move optimism R to the left, and we'll move optimism to the dependent variable. Now we must change only one option, and this option is here in criteria in the growth limits, because yesterday we very briefly discussed samples, and I said nothing about the sample size, but in statistics, when we estimate percentages, then the minimum sample size is 50 cases, 50 persons. But if we estimate means, average means, that the minimum of the sample size is 30. So here, in minimum number of cases, in so-called child node, I will change and we'll write 30. And here in parent node, we also will change 2 times 30 is 60. But what does that mean parent node, and what does that mean child node? Let's press continue OK. In the tree, this node is parent, these nodes here are child, and again this node is parent, these two nodes are child. So this is the new tree with the same independent variables, but we changed dependent variable. And now you can see here that already independent variables included in the tree in the model are 3H, the most important, a major source of stress, the second most important, and do you have any children currently living at home with you, the third most important independent variable. Total number of nodes is now 10. Terminal nodes are now 7. And depth of the tree, levels of the tree are 2. And here is the tree. But again, here we have table. This table is similar to this table here with percentages, but here we have means, we have average means. So we can see that in node number 5, the average score of optimism is highest. And in node number 7, the average score of optimism is lowest. And we can see these nodes on the tree, in the tree. So node number 5. Node number 5. Here is node number 5. Since the age is the first most important dependent variable. That means that in note number 5 are persons who are older than 50 years of age. Their age is larger than 50 years. And these persons are most optimistic. Most optimistic. Note number 7. Note number 7 is here in the second level of the tree. So we have pass through the branch of the tree. First, age less than or equal to 29 years, and after that, a major source of stress. And here we have major sources, money or finances, children, health or illness, relationships, spouse or partner, and missing. So, if one particular person is younger than 29 age of years, and in his or her life, money, finances, children, health, illness, relationships, spouse, partners are major sources of stress, then this person will be less optimistic. So this was the interpretation of the tree when the dependent variable is interval variable. I have presentation for this topic, also a presentation, but I decided to show you with SPSS. Presentation is almost the same. I will upload in Moodle. I will upload both video and presentation. Here is the presentation. The examples are the same, and the results are also the same. Here, different steps of analysis are shown. Okay. The most optimistic and the least optimistic. Note number 1, note number 4, and with interval dependent variable. Okay, the results are the same here. So this was very briefly last topic about the classification tree or classification trees. Questions?
I don't have.
Okay.